Today I will discuss about the strength of a surplus shaft. At first, what is strength? The maximum power or torque that a shaft can transmit from one pulley to another. This is strength of a shaft. Now we have to calculate the amount of strength. That means torque transmitted by the shaft. Or it may be said that prove that T equal to pi by 16 Fs dk. Yeah. Now this is a solid circular shaft of radius r subjected to torque T. Yeah, subjected to torque T, and due to which maximum shear stress Fs induced at the outermost layer of the shaft. Okay. Now assume a thin elementary layer. Thin elementary layer, yeah, of thickness dx at a distance x from the center of the shaft. Now at first the area of this elementary layer, this is 2 pi x dx. But how? If this elementary layer is developed here, yeah, this is elementary layer, and the perimeter, this is 2 pi x, this is 2 pi x, and thickness, this is dx. So length into breadth, this is area, this is 2 pi x into dx. Okay. Now if shear stress Fx induced at this elementary layer, so what is the value of Fx? Yeah, on the previous class we proved Fs by R, that is equal to c theta by L. Here c shear modulus, theta angle of twist, L length of the shaft are constant. That means these are constant. So Fs by R equal to constant. So it may be said in this way: Fs by R. Fs maximum shear stress, radius, this is R. Here at this thin layer, shear stress, this is Fx, and distance x. So here Fx equal to x into Fs by R. Yeah. Now so this is Fx equal to x into Fs by R. Okay. Now we know that stress equal to force per area. So force equal to stress into area. That means here force equal to stress into area. Now putting the value, Fx equal to x into Fs by R, area, that is 2 pi x dx. So this is 2 pi Fs by R x square dx. Yeah. And we know the definition of torque, the product of turning force and the perpendicular distance. So now this turning force into distance, this is called torque transmitted by this elementary layer. Yeah. Now putting the value, Fx equal to 2 pi Fs by R, this is x square dx, and this is x. Yeah, this is actually Fx. Yeah. So the value, this is 2 pi Fs by R xq dx. Yeah, if the torque transmitted by this elementary layer, this show the total torque transmitted by the whole section. This is total torque transmitted by the whole section, integration 0 to r, this 2 pi Fs by R xq dx, the torque transmitted by the thin layer. Yeah, now here variable is dx, so 2 pi Fs by R, this is constant, integration 0 to r xq dx. Yeah, now look at this is t equal to 2 pi Fs by R and integration xq, x to the power n plus 1 by n plus 1, that means here x to the power 4 by 4, lower limit to upper limit. Now here 2 pi Fs by R, putting the value of upper limit, this is r to the power 4 by 4 and this is 0. Yeah, so here 2 pi, this is 2 and 4, that means pi by 2 Fs R and r to the power 4, this, that means Rq. This is total torque transmitted. Now if you convert this radius into dia, that means here this is t equal to pi by 2 Fs, here d by 2 whole cube. Yeah, that means 8 here and 2 into 8, this is 16, that means pi by 16 Fs dq. Yeah, and the torque transmitted by the whole shaft here, this is pi by 16 Fs dq. And look at, if dia is increased, then torque transmitted will be increased. Okay, and so thank you.